Hi, good morning, dear students. Today I am taking another chapter, that is chapter number 10, gravitation. Gravitation. So, the, the attractive force, for example, magnet attracts an object, so that is related to magnetic effect. So now this gravitational force is related to dash. So for which object this gravitational force it belongs? So come with me the answer. So it is a one type of attractive force, and in this chapter we are going to learn about gravitational force and force of gravity, and that is also known as universal law of gravitation. Then importance of universal law of gravitation, then the meaning of free fall and value of small g as well as value of capital G, and the next one is motion of objects under the influence of gravitational force of the earth, and thrust and pressure, buoyancy, and the Archimedes principle, and relative density, and some problems related to gravitational force. So now, gravitational force means it is the force of attraction by the earth towards the object. So that means earth attracts every object in the universe. Okay, for example, if we throw a pen upwards, it comes in downward direction. That is because of gravitational force. And in previous class, we may learned about the value of small g. Value of small g. So this small g is called as acceleration due to gravity. This is called as acceleration due to gravity. And everyone knows the value of small g. What is the value of small g? Come and be the answer. What is the value of small g? First, then comment me what is the value of small g in gravitational force. So small g is known as acceleration due to gravity. Anyone knows the answer? So this value of small g is 9.8 meter per second square. 9.8 meter per second square. Okay. So 9.8 meter per second square. Here meter per second square. So this is the SI unit of acceleration also. So here small g is known as acceleration due to gravity. So this is the increase in the velocity with respect to time because of earth gravitational force. Okay, that's why the unit is also meter per second square. And in this chapter we are having two g's. One is small g and another one is capital G. And a capital G is known as gravitational constant. Gravitational constant. And small g is acceleration due to gravity. Okay, here the gravitation means it is the force of attraction by the earth towards any object. In this, we will learn one of the very important concept, that is universal law of gravitation. So what is meant by universal law of gravitation, and what is the expression for universal law of gravitation, and what are the SI units which comes under the expression, we are going to learn here. So that is present in page number 132, universal law of gravitation. Universal law of gravitation. According to this, every object in the universe attracts every other object with a force which is proportional to masses and inversely proportional to square of the distance between them. The forces along the line joining the centers of the two objects. Okay, I will write the definition here. Every object in the universe attract every other object with a force with a force which is proportional to with the force which is proportional to product of the masses which is proportional to product of the masses and inversely proportional to square of the distance between them. Square of the distance between them. Here between them means between the two objects. Okay, just read that law statement once again. Every object in the universe attract every other object with a force which is proportional to product of their masses and inversely proportional to square of the distance between them. Okay, this is very important statement, and this derivation is very important derivation, and the expression is also very much useful. Now we have to divide this statement into two parts to get the expression for forcing. In previous chapter, that is force and laws of motion, we have two formulas. We have one expression, that is F equals to ma. That is mathematical statement of Newton's second law of motion. In that, according to that statement, we have the acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. And we divided that statement into two parts. Okay, first one related to acceleration and force, and second is related to acceleration and mass. Now similarly, in this law, it is given that every object in the universe attracts every other object with a force which is directly proportional to product of their masses and is inversely proportional to square of the distance between them. So first we will take the first part, that is force and product of the masses, and second we will consider force and square of the distance between them. Here product of the mass is directly proportional to force, and square of the distance between the two objects is inversely proportional to the force. Okay, based on these two statements, we will derive the expression for universal law of gravitation. For that, we will consider two objects. And these are the centers of the two objects. I'll consider this as object A and this as object B, and I'll consider the distance between two objects is D. I'll consider this as O1, O2. That means center 1 and center 2 of the object. First we will write what are the given data here. So what are the given data? Consider two objects. Consider two objects A and B, of masses M and M. One is capital M, another one is small m. So here A is the bigger object. So for that I will consider capital M as the mass, and object B is smaller object. For that I will consider small m as the mass. Okay. One is capital M, that is mass of the object, and distance between the two objects. Distance between the two objects B, D. So here we consider two objects, object A and object B. Object A is having the mass capital M and object B is having the mass small m, and the distance between the two objects, that is from the center, it is D. So this is the main requirement here. So now we will consider the statement, and according to the statement we will divide the statement into two parts. Okay, first one, force is directly proportional to product of the masses. Product of the masses of the two objects. The force of attraction between the two objects, or force, is directly proportional to product of the masses of the two objects. So that's why it becomes F is directly proportional to capital M into small m. We will consider this as equation number 1. Capital M is the mass of the first object and small m is the mass of the second object, and here the force of attraction between the two objects is directly proportional to product of their masses. So that's why it becomes F is directly proportional to M into M. Just look at the steps. How many of you understood till now? Fast. Come into name. So here we have to remember the statement of universal law of gravitation. According to universal law of gravitation, every object in the universe attracts every other object with a force which is directly proportional to product of their masses, and it is inversely proportional to square of the distance between them. So then this is the first part. Then I will grab this. Then the second part of the statement is the force of attraction between the two objects is inversely proportional to square of the distance between them. Force of attraction between the two objects. Between the two objects is inversely proportional to square of the distance between them. Square of the distance between them. So the force of attraction between the two objects is inversely proportional to the square of the distance between them. That's why this expression becomes F is directly proportional to 1 divided by d. So distance between the two objects is d. Square of the distance between the object means d square. And force is inversely proportional to square of the distance between the two objects means F is inversely proportional to d square. So to read this statement, we have two methods. So first one is F is inversely proportional to d square. So the d square is in the denominator, that's why we can directly use force is inversely proportional to d square. Otherwise we can read this as force is directly proportional to 1 by d square. First method is force is inversely proportional to d square, and the second method is force is directly proportional to 1 divided by d square. So these are the two methods to read the statement 2. So I will call this as equation number 2. So equation 1 is F is directly proportional to m into. Equation 2 is F is directly proportional to 1 divided by d square. So that's why combining equation 1 and 2 becomes. Now I will combine this equation first and equation 2. Combine equation 1 and equation 2. So it becomes F is directly proportional to m into m divided by d square. F is directly proportional to m into m divided by d square. Then now again we have to remove the proportionality symbol. So this is proportional symbol. Now we have to remove that. When we want to remove the proportional symbol, we must add a constant term. So that's why here I will take F equals to g into mm divided by d square. Here g is proportionality constant. Here g is proportionality constant. Just look at the step. Here g is proportionality constant. How many of you understood this? First, see, it is just like deriving Newton's second law of motion. First, we consider the first part of the statement, and mathematical statement becomes F is directly proportional to m into m. And in the second part, the mathematical statement becomes F is directly proportional to 1 divided by d square. When we combine equation 1 and 2, it becomes F is directly proportional to m into m divided by d square. And to remove proportionality constant, proportional symbol, we have to add one constant term. So that's why it becomes F equals to g into m divided by d square. So this is the expression for force of gravitation. F equals to g into m divided by d square. That means F equals to gravitational constant. That means force equals to gravitational constant into mass of the first object into mass of the second object divided by square of the distance between the two objects. So this is the mathematical statement of universal law of gravitation. That is F equals to g into m divided by d square. Now we know the SI unit of force. SI unit of force is Newton, and mass, m is mass. SI unit of mass is kg. Small m is also mass, and SI unit of that mass is also kg. And d is the distance between the two objects. Okay, and for the distance between the two objects, we are measuring that with the help of meter. And here it is d square. So distance between the objects square. So therefore unit is also meter square. So now we want to find out the expression for capital G here. Expression for capital G, and what is the value of capital G. So that is given in page number 134. Page number 134. First we have to rearrange this expression. First we have to rearrange this expression. So when we cross multiply this, it becomes F into D square, that is equals to G into mm. But we want only G. So therefore G value becomes F into D square divided by m into m. So this is the expression for gravitational constant. Okay, capital G is the symbol which is used to represent gravitational constant, and expression for gravitational constant is G equals to F into D square divided by M into M. So this is the expression for gravitational constant. Now we'll substitute the SI units of all these terms. So it becomes G equals to forces in terms of Newton and D square is in terms of meter square. Mass capital M is in terms of kg and small m is in terms of kg. That's why it becomes G equals to Newton meter square per kg into kg, it becomes kg square. So therefore SI unit of capital G is Newton meter square per kg square. The SI unit of capital G is Newton meter square per kg square, or we can write Newton meter square kg raised to minus 2. Okay, Newton meter square per kg square, or Nm square kg raised to minus 2. This is the SI unit of gravitational constant. Okay, SI unit of gravitational constant, and value of capital G and value of capital G is 6.673 into 10 raised to minus 11 Newton meter square per kg. Okay, 6.673 into 10 raised to minus 11 Newton meter square per kg square. The value of G was found out by Henry Cavendish. He lived between 1731 to 1810. By using sensitive balance, the accepted value of G is 6.673 into 10 raised to minus 11 Newton meter square per kg square. So the founder of this is Henry Cavendish. He used sensitive balancing method to calculate the value of capital G. Just read the values and remember the values too. Based on the universal law of gravitation statement, we derived the expression for capital G and also capital F, and the value of capital G is 6.673 into 10 raised to minus 11 Newton meter square per kg square, and its SI unit is Newton meter square per kg square, and capital G is known as gravitational constant. How many of you understood this? It carries nearly 3 or 4 marks, and the value of capital G and SI unit of capital G comes for 1 marks. Then the next one, importance of universal law of gravitation. What are the importance of universal law of gravitation? So here gravitational force is useful in every aspects in our daily lives, and here they give very important 3 universal law of gravitation uses. They are the force that binds us to the earth, the force that binds us to the earth, and next one is the motion of the moon around the earth. Third one, the motion of planet around the sun. The fourth one, the tides due to the moon and the sun. Okay, first one, the force that binds us to the earth, If the force of gravity is not present, if force of gravitation is not present, then we can't able to walk on the roads, because if there is no attraction force, if we jump, we will remain in the jumping state. Okay, many astronauts you saw in when they are on the surface of moon, so that the attraction force is, when it is less, so they can't able to reach the ground. Okay, this is the main use. Force that binds us to the earth. Second one, the motion of the moon around the sun. Motion of moon around the sun. Around the sun. Next one is the motion of planet around the sun. Motion of planet around the sun. Around the sun. And next one, the tides due to the moon and sun. The tides due to the moon and sun. In all these aspects, the universal law of gravitation helps. And the statement of universal law of gravitation states that every object in the universe attracts every other object with a force which is directly proportional to product of their masses, and it is inversely proportional to square of the distance between them. Just read the four very important use of universal law of gravitation. Okay, these are the four uses, important uses. Then the next one. So just now we found the expression for capital G, and the expression for capital G is F into d square divided by m into m. F into d square divided by m into m. This is the expression for gravitational constant. Now, by using the statement of universal law of gravitation and by using the statement of Newton's second law of motion, now we have to derive the expression for small g, and small g here it is known as acceleration due to gravity. Okay, acceleration due to gravity. I'll use the statement. According to universal law of gravitation, universal law of gravitation, so what it states that F is directly or F is equals to G into mm divided by d, G into mm divided by d. And according to Newton's second law of motion, where it is applied to when the acceleration is same as the gravitation. According to Newton's second law of motion, according to Newton's second law of motion, F equals to m into a. When acceleration is same as gravity, when acceleration is same as gravity, then this expression becomes F equals to m into g. I'll call this as equation number 1 and this as equation number 2. Again, both left hand side are equals to capital F, that is force. And according to the axioms, we know that if two things are equals to same thing, then that two things are equals to each other. So right hand side of equation 1 is equals to F. Similarly, right hand side of equation 2 is related to F. Therefore, by combining or comparing equation 1 and 2, it becomes m into g, that is equals to g into divided by d square. Okay, G into divided by d square. So if we consider capital M as the mass of the earth, so then what happens? So here gets cancelled and the expression for G is Gm divided by d square. Gm divided by d square. This is the expression for small g. That is, small g means here acceleration due to gravity. How many of you understood this? Just comment your name and click on the like button. Fast. So expression for small g is G equals to Gm divided by d square. Okay, then next. Now already we found the expression for small g. Now we have to calculate what is the value. So here if you consider capital G as gravitational constant and capital M as the mass of the earth and d is the radius of the earth. For example, if an object is present on the surface of the earth, then the distance between the two objects is the same as the radius of the earth. Okay, so that is given in page number 135. To calculate the value of G, we should put the value of G, M and R in the equation. Universal law of gravitation as 6.673. Here they consider only 6.67 for the simple calculation into 10 raised to minus 11 Newton meter square per kg square. And mass of the earth, capital M as 6 into 10 raised to 24 kg, and the radius of the earth is 6.4 into 10 raised to 6 meter. Okay, what we have to consider here, G is gravitational constant. Gravitational constant, and its value is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Okay, Newton meter square per kg square. And next, capital M is mass of the earth. Mass of the earth, and mass of the earth is 6 into 10 raised to 24 kg. 6 into 10 raised to 24 kg. And for example, if we consider this as earth, and if an object is present on the surface of the earth, then the distance between the center of the two objects is same as a radius of the earth. Okay, distance between the center of the earth and center of the object. So in which case, when the object is on the surface of the earth, that is same as radius of the earth. Therefore, d is radius of the earth, and its value is 6.4 into 10 raised to 6 meter. 6.4 into 10 raised to 6 meter. And now here we have the expression for small g, that is G equals to Gm divided by d square. So just I will substitute here the values of capital G, capital M and d. So it becomes G value 6.673 into 10 raised to minus 11 into capital M values 6 into 10 raised to 24 divided by d values 6.4 into 10 raised to 6 whole square. 6.4 into 10 raised to 6 whole square. Just I will simplify the powers of 10 here. So it becomes 6.673 into, I will consider 6 into 10 raised to minus 11 into 10 raised to 24 divided by 6.4 square into 10 raised to 6 square. So it is same as a into b whole raised to m, that is equals to a raised to m into b raised to m. So this is the small formula which we used in exponent. That's why it becomes 10 raised to 6 to the 12. Okay. So when we take this 10 raised to 12 to the numerator, it becomes 10 raised to minus 12. Therefore, by simplifying all this, we will get the value of small g as 9.8 and SI is meter per second square. 9.8 meter per second square. Just look at the step. So this is a method of deriving the value of small g. This is the value of small g. Value of capital G is 6.673 into 10 raised to minus 11 Newton meter square per kg square, and mass of the that is capital M is 10 raised to 24 kg, and radius of the earth is 6.4 into 10 raised to 6 meter, and we found the value of small g, that is acceleration due to gravity, or gravity value, that is 9.8 meter per second square. Okay, then another word comes, that is free fall. Free fall. What is meant by free fall? So, if an object is present, then on that object plenty number of forces are acting on that. Gravitational force, one of that, and apart from that, frictional force and applied force. If we applied some kind of force, then that is also present on that. So here we have one word, that is free fall. If one object is falling on the earth, to the surface of the earth, that is only because of gravitational force. If an object falls only because of gravitational force, then that is known as free fall. Okay? If an object falls only with the influence of gravitational force of the earth. Gravitational force of the earth is called as free fall. So what is known as free fall? If an object falls, or if on an object if only gravitational force is acting, then that is known as free fall. How many of you understood all this concept? That is universal law of gravitation and the statement, its derivation, what is the value of small capital G, what is the value of small g, and what is meant by free fall, and you have to remember the values of mass of the earth and this radius of the earth. They are very, very important, because if they ask find out value of small g, then so you have to write the expression of small g, that is gm divided by d square, and in that you have to substitute the values of this. If that is given, then no problem. If that is not given, then we have to substitute the values directly, and we have to find the value of small g. Okay, SI unit of capital G is Newton meter square per kg square, and SI unit of small g is meter per second square. Small m bar small s also. Okay, and value of capital G is 6.673 into 10 raised to minus 11 Newton meter square per kg square, and value of small g is 9.8 meter per second square. Okay, 9.8 meter per second square. I will continue the remaining in the next class. Thank you very much.